Hello and welcome to this week's video, which is going to be about quiz number 4, which is due on Wednesday. And here's a preview of the questions. If you go to the study plan, you can practice these questions. Of course, practicing before the quiz would be a good idea. And then I want to look at some examples. A thief steals an ATM card, has to randomly guess the 5-digit PIN code from a 6-key keypad. So basically, there's the numbers 1, 2, 3, 4, 5, 6 on the keypad. Repetition of digits is allowed. What's the probability of getting the correct guess in the first try? So when they guess, there's a 1 in 6 chance that they're right. And then they would have to do that 5 times in a row. So you could either put 1/6 times 1/6 times 1/6 times 1/6 times 1/6, or you could say that is 1/6 to the 5th power. Let me see if I can get the calculator to show up. So then 1/6 raised to the 5th power. It's not showing up, is it? Ah, well. So that turned out to be 0.0001286. Put an integer or a fraction, simplify your answer. So now I really do need this to show up. There we go. Can't see anything else, but now you can see the calculator. So once I typed in the 1/6 to the 5th and make sure I put parentheses, then just go over here to math and change it to a fraction. And that's going to be 1/7776. Turn the lights back on. So that's 1/7776. The probability that it's correct. Oh, this said the number of possibilities. So the number of possibilities is 7776, the bottom part of the fraction. And then the probability, that is the whole fraction. So the chances that they could do that would be very, 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 very small. And then on to another question. So you've got this table. These are restaurants, A, B, C, D. Was the order accurate or not? Like you go and you say, I would like a hamburger with only tomato on it. And then they put onion and mustard on it. That is not accurate. So find the probability of getting an order from restaurant C or an order that is not accurate. So restaurant C, that's these two. So that's going to be, so for restaurant C, that's going to be 236 plus 37. Or it's not accurate. So not accurate would be this row right here. So that would be so for this one, this row for being not accurate, that would be 35 plus 59 plus 37 plus 20. And for C, notice I didn't write anything down right yet because I wanted to see what was going to happen. C has a 236 plus a 37, but the thing is I already counted the 37 right here. So for C, I should only count this extra 236. Now I need to add all those together. So I'm going to do that. Oh, the calculator is showing up a little bit better right now. Oh, that's because it was dimmed. Okay, I'll just do that off screen. So 35 plus 59 plus 37 plus 20 plus 236. So this in total is 387. Now that's going to be the top of the fraction, 387. And the total of all of these orders, that's what's going to be on the bottom. So I already got 387. Now I just need to add in this one, 139. So plus a 139. This one hasn't been counted yet, 271. So plus another 271 and plus a 331. So the grand total is 1128. Round this to 3 decimal places. Let me have it concentrate on the calculator now. So 387 divided by 1128. So I already went to the mode and changed my calculator to 3 decimals. And that way it gives me the answer in 3 decimals, 0.343. .343. Are the events of selecting an order from restaurant C and selecting an inaccurate, are they disjoint? Well, you could see that inaccurate is here and C is here, and they're joined right here. So it could happen that you go to restaurant C, it actually happened to these 37 people right here. They went to restaurant C and their order was not accurate. So are they disjoint? No, the two events are, or the events, oh, I see, they even have singular and plural. Okay, so the events, I need plural, and they are not disjoint, are not, which is sort of weird because this means not, and so this is a double negative. So 2 negatives will cancel each other out because they are joined. They're joined right there at the 37. And because it is, oh, I see, this part goes over here. So it is possible to receive an inaccurate order from restaurant C. Yes, because that's what happened to those 37 people. So then that one goes right there. All right, let's see what other fun we can have. So this one is similar. For one thing, I should get the total. How much is all of this when you add them up? So this would be 65, 66, 76, 106, 109. So that's the total. Find the probability of a false positive test. So a false positive means it tested positive saying yes, they're using drugs, but they really weren't. So if you're not a drug user and yet you get a positive test result. So for these 20 people, they just got ripped off because they have not been doing drugs and yet the test said they have been doing drugs. So that would be 20 over 109. Round it to 3 decimals. So 20 divided by 109. So that's a 0.183, which is actually pretty bad news because that means 18% of the time people are being accused of being a drug user when they're not. Who would suffer from a false positive and why would they suffer? The person tested would suffer because he or she suspected, and in reality, oh, my sentence got cut off over there. Let's see if I can answer it. The employer would suffer. No, the employer's not going to suffer when these people were wrongly accused. Because he were not suspected. That's not true because they were suspected because they got a positive test. So this one's not right. Not the employer, not them. The employer would suffer. No. So it must be A. The person that was tested, they would suffer because she or he would be suspected of using drugs when in reality, they do not use drugs. And what else is there to look at? Whoa, that's a lot of words. So in here, there's male. So use capital M for male. And then B is blue eyes. So what does this conditional probability mean? So when it's got this straight line right here, it means this has already been determined. So you know that the person has blue eyes. And now what's the probability that the person is male, given that you know they have blue eyes? So which one is that? What's the probability of a male or? No, it's not or. So the word for this one is given or conditional probability. It's not the word or. The probability of getting a male, given, yes, that's the right word, that someone with blue eyes has been selected. There it is, it's B. Oh, the answer's right there because I got the teacher's version. That's funny. Are these the same? No, they're not the same because this is saying given you know that they have blue eyes, then what's the probability they're male? Then this is saying given you know that it's a male, now that you know that it's a male, what's the chances they have blue eyes? So I know that they're not the same, so it's going to be one of those two. So this one represents the probability of getting someone with blue eyes, given that a male has been. So this is basically putting into words exactly what this symbol means. So the probability of blue eyes, given, and that's the straight line right there. So it's that one. Oh, there it is, B. Next up, in a state pick 4 lottery game, a bettor selects the 4 numbers between 0 and 9. And any number could be used more than once. So someone goes in and say, okay, I'm going to buy the winning lottery ticket. And the selected numbers can be used more than once. Okay, so my winning lottery ticket is going to be 1212. That's my winning lottery number. So that's the idea. So they have to be drawn in the same order. So in other words, if the lottery announces, oh, we have the winning numbers, it's 2, 1, 1, 2, and you go, look, I won. And they go, no, you did not. It has to be in the correct order. So do the calculations involve combinations or permutations? Why or why not? So let's see. The combinations and permutations rule do not apply because repetition is allowed. I'm liking that answer because permutations would be something like you have horses in a race and horse number 9 came in first, horse number 3 came in second, and horse number 1 came in third. So when order matters, that's going to be permutations. But you cannot have horse number 9 got first place, horse number 9 was so good, he also got second place, and horse number 9 is so good, got third place as well. No, that can't be. So that is when there's permutations. But this is allowing repetition of numbers, so it's not going to be permutations. So I'm liking answer A. What about this? Combination permutation does not apply because repetition is allowed and the numbers are selected. Dang, like it got cut off right there. I don't know what it says after that. I don't know. The combination rule applies. Nope. The permutation rule applies. Nope. Because there's repetitions. The permutation rule applies. Nope. because there's repetitions. So I'm thinking that the answer is A. Oh, it says down here, because the repetition is allowed, so that's how come it's not permutations or combinations. And numbers are selected with replacement. So the multiplication counting rule is what applies. So basically, if you wanted to know how many possibilities there are, you would then go like this and say, all right, we're using the numbers 0 through 9, so there's 10 of those numbers. That's 10 digits. And because they could be repeated, there's going to be 10 possibilities. And then for the next one, you could repeat, so 10, and then 10, and then 10. So the multiplication rule is what would be needed on that one. And then Blackjack. Well, happens to be that sitting right here, I've got some cards. That is considered a 20. That's not a blackjack. But if I had this, that would be a blackjack. An ace and a 10 card. So like that would be a blackjack. That would be a blackjack, but you need one ace and one card that's worth 10. Oh, and the other thing is, right here I have the jack first and the ace second. Well, if it goes this way, and you have the ace first and then the jack, you still have blackjack. So then, put the cards away and let's do some math. Okay, so for a blackjack, I would do it like this. You have an ace and a 10 card. Or it could be that you have a 10 card and an ace. Now, or means you add the two possibilities together. Now for an ace. So there's actually 4 aces and there's 52 cards total. And means you multiply. Now for the 10 cards, well, there's 4 tens, there's 4 jacks, which are worth 10 points, there's 4 queens, and there's 4 kings. So that would be 4, 8, 12, 16. So that's what they're talking about right over there. So 16 possibilities. And because I already, for my first card, I already got dealt an ace. Now for the rest of the cards, see how many cards there are? There's only 51 left because I just took one out. So this is 51. Now, if you put a 10 card first, like that, well, there's 16. And now I'm starting all over because I've reshuffled the deck. So there's, again, 52 cards. And then I got the 10 first. And now for aces, there's 4 aces and there's only 51 cards. So what does that equal? Because it says put a simplified fraction. And have it zoom in on the brightness of the calculator. So it is 16 divided by 52 times 4 divided by 51 plus 4 divided by 52 and 16 divided by 51. And then just go over here to the math key and change that to a fraction. So that is 32 out of 663. And then it says change that to, so I want to do it again, but I want to take off the part where it says change it to a fraction, and I don't feel like retyping it. All right, so this is the decimal form. Then to change it to a percent, multiply by 100. So that is, it says 2 decimals. So the 7's going to round it up. So it's 4.83%. And since that's less than a 5% chance of happening, that would be considered unusual. Turn the lights back on. And there's just one more that I wanted to do. A genetics experiment on peas, one sample of offspring had 412 green and 143 yellow. Well, the first thing I need to do is add those two to see what's the total. So that would be a 5, a 5. Oh, nice, it's 555. So this is the total. The probability of getting a green, so that would be 412 out of the 555. And I'll just do that on the side. 412 divided by 555. So that's a 0.742. Type an integer or decimal rounded to 3 decimals. Good work. There we go. So is this reasonably close to 3/4? Well, 3/4 is equal to 0.75. 0.74, is that close to 0.75? Yes, it's reasonably close. All right, that's the end of today's show.